Okay, guys, we're back with part 3 of lesson 419. We're actually going into Article 312. And so for the next little bit, we're going to be talking about Article 312. Some tricks to this conversation. As you listen to this, you're going to need to write down any questions you have, and then just kind of go from there accordingly. I'm sure there's going to be slides you're not sure about. Keep good questions, go from there. Okay, this article mainly covers cabinets, cutout boxes, and meter socket enclosures. Okay, 312.1 scope explains that type of situation. One of the main purposes of going through this again with you guys is so you can see potentially some of the changes from 2017 to 2020 as you guys are preparing for your test. Damp and wet locations. Okay. 312.2, wet locations, cables and raceways entering above uninsulated live parts must use fittings listed for wet locations. It's kind of an obvious description. It kind of also explains why the use of Myers hubs are so important, or service entrance hubs, those type of things. In wet locations, cables and raceways entering above uninsulated live parts must use fittings listed for wet locations. 312.4, repairing non-combustible surfaces. Okay. Flush mounted enclosures in combustible surfaces can have a maximum 1/8 inch gap around them. Larger gaps must be repaired. That includes things like later in the code you're going to see receptacle situations, but cutting out something with just a huge gap ends up being a problem. Could potentially be a code violation. Okay, so we're repairing non-combustible surfaces. You got a raceway, PVC raceway, less than 24 inches long, contains 11 14.2s and 7 12.2 NM cables, non-metallic cables. Table 1 of Chapter 9 allows 40% fill for more than 2 conductors. Note 4 allows 60% for raceways 24 inches or less in length. That allows us to use nipples to get stuff down into panels. Table Note 9 requires elliptical cables to be calculated using the long dimension of the ellipse as the diameter for determining cross-sectional area. Okay. Table 4 provides the internal raceway area. So these are these tables we were talking about in the breakdown. For example, looking at this, you've got a 14.2 in inches. The nominal cable outer diameter is 0.39. Okay, so it's flat cable. You guys know this. It's elliptical. It's that 0.17 by that 0.39 is the size, length times width. Okay, 12.2 is that 0.16 times 0.15. I'm sorry, 0.45. Okay, so looking at that, the cable fill example with 11 12.2s, okay, we got to use that 0.45, and 7 14.2s, 0.39. You see where you got those? Straight off the table, the area equals pi r squared. And the radius is half the diameter, so r being the radius. So the 12.2s You got that 0.45 divided by 2, 0.225 radius. 0.225 squared is 0.05. 0.05 times pi, 3.1415, is 0.159 per cable times 11 means you've got 1.75 square inches total. Following the same math with the 14.2, you end up with 0.836 square inches total. So now you have to continue on Article 352 and 353, rigid PVC conduit, Schedule 40. Looking at that cable fill, 1.75 and 0.836 is 2.586 square inches total. So table 4, Schedule 40 PVC, that 60% column, there's where that 60%. Trade size 2.5 inch Schedule 40 is required in order to get that information. Okay. So looking down this column, this is the 60% fill, which is what you're allowed because it's under 24 inches. This is the total fill you have. So that lets you know that it's got to be at least a 2.5. A 2 inch is 1.79. Sorry, 1.97. A 3 inch is 4.36. You could do that if you want to do spare room, things of that nature. But it doesn't make sense to do that. So enclosure openings, 312.5C cables. Exception 1, non-metallic cables can enter the top of a surface-mounted enclosure through a non-flexible raceway that is between 18 inches and 10 foot long if non-metallic cables can enter through the top, if non-flexible raceway, if one, so all of them have to apply, all apply. 1, each cable is secured within 12 inches of the raceway. And 2, the raceway doesn't penetrate a structural ceiling. And 3, a fitting is provided on the end of the raceway to protect the cables, and the fitting must remain accessible. Okay. 4, raceways must be sealed at the end, and then cable sheath must be continuous through the raceway and extend into the enclosure at least 1/4 inch. 6, raceway must be secured, which is obvious. And 7, cable fill must not exceed Table 1 of Chapter 9 and its notes, other than Note 2. Okay. Single conductors or multi-conductor cables leaving cable trays may enter enclosures through a raceway or flange without being secured to the enclosure. Okay. So that cable fill example being continued, you got that 1.75 and that 0.836 that we calculated earlier. It's 2.586 square inches total. Schedule 40 has showed us that the 60% column, that we've got that 2.5 inch PVC, and that's what's required. Okay. So enclosure openings going on, each cable must be secured to the cabinet, cutout box, or meter socket enclosure. Okay. 312.6 says that cabinets and cutouts, cutout boxes, must have a gutter space that complies that Table 312.6A Wires per terminal is the number of conductors in parallel as applicable. Okay, so 312.6a requires 6-inch gutter space for two 4-aught AWG conductors. Table 312.6a requires 6-inch gutter space for 500 kc mil conductors. The reason they start laying this out is so that you can start getting into your wire bending radiuses and spaces around it. Okay. 312.6b wire bending space. There is no bending radius requirements in the code for individual conductors operating at 1,000 volts or less. Okay. This is one that tends to get argued a lot. Now, I will tell you this about the bend radiuses of the conductors. They can intrinsically have effects on AFCIs and GFCIs. So that's one thing you want to kind of be clear of the implications if that happens. There's no bending radius requirements in the code for individual conductors operating at 1,000 volts or less. Okay. So conductor deflection. We're talking about compact aluminum has no interstitial space between strands. So there's no space in there. Table 312.6a requires 5-inch gutter space for two 4-aught compact aluminum. Compact aluminum conductors are allowed to use the second column of the table. .6b, the wire bending space. 312.6a requires 6-inch gutter for these two 4-aughts. Table 312.6a values are allowed if conductors do not enter or leave the enclosure through the wall opposite its terminals. Okay. I'm going to repeat that again. Table 312.6a values are allowed if conductors do not enter or leave the enclosure through the wall opposite its terminals. So its terminals enter through the wall would be this right here. Okay, that's its terminals. That'd be opposite. So that's the 312.6a. Now, table 312.6b values must be used if the conductor enters or leaves through the opposite wall. So through the opposite wall here, that's where that 14 inches. So table 312.6b requires 14-inch bending space for 500 kc mil because it's entering through the bottom. Deflected conductors, conductors entering or leaving enclosures or at terminals must have gutter space in accordance with 312.6a and wire bending space in accordance with 312.6b. And I'm sure that James is going to open this up and look at it a little bit more in depth as we get through this. Okay. So now enclosures with switches and overcurrent devices. So 312.8a splices, taps, and feed through conductors. Okay. So a 3-inch, you can see the 3-inch by 3-inch wiring space is 9 square inches. Okay. So 9 square inches times the 0.4, 40% is 3.6 inches allowable for conductor fill. So, according to Chapter 9, Table 5, number 12, THHN, has 0.0133 inches. Okay? 3.6 inches, which is the 40% of the 9 square inches we have, divided by the number 12 square inches. So the diameter, the area of 0.0133. You have a total of 270 12-gauge conductors allowed in that wiring space. Now, it seems crazy because if you think about packing 212 conductors in there, if that is it looks like a 30-circuit panel, and everyone had its own neutral and ground, and they all came from passing through that space, that's 120 conductors maximum that you would have in that raceway, or in that space anyway, in that cavity anyway. The total area of conductors at any cross section of the enclosure must not exceed 40% of that cross-sectional area. Number 2, the total area of conductors, splices, and taps must not exceed 75% of that cross-sectional area of the space in which they're installed. Conductor splices and taps . 312.8a, we're still there. The wiring space in enclosures may contain conductors that feed through, are spliced, or are tapped as indicated in 312.8a1 through a3. The equipment must be a field installed accessory for listed equipment or as a listed kit for field installation. So enclosures were still under 312.a. Enclosures with switches and overcurrent devices, panel boards, load centers. The equipment must be a field installed accessory for listed equipment or listed kit for field. And so to be inside that enclosure, it has to be identified as such. It's got to be field installed accessory for that equipment or a listed kit for field installation. The total area of all conductors, splices, taps, and equipment must not exceed 75% of the cross-sectional area they are installed in. So the size of this stuff becomes imperative when you start putting, like, these are CTs that are monitoring power, potentially power quality. All of that together must not exceed 75%. Okay. So we're moving on. 312.8. 1 through 3. So they must be routed along the perimeter, secure at 10-inch maximum spacing, with 10-inch of terminations, and prevent contact with any other components. 4 and 5, they have to be rated for the system voltage, but at least 600 volts and 90 degrees Celsius. The violation here. James will review that violation on that slide. 312.8 B3, conductors. Control and instrumentation conductors, A, must comply with 725.49 for class 1 conductors, or B, if smaller than 18 but not larger than 22 for individual conductors, or 26 for a cable. And it says they must, okay? It's mainly going to be power monitoring or energy management equipment. So these energy management systems is either equipment that's listed for the manufacturer, so it's been listed per the manufacturer, or it's equipment that has been listed for that application. And they added this energy management because you're going to be monitoring power. You're going to have an EMS that's going to monitor, and it's going to turn stuff on and off as needed to save power. This kind of establishes the criteria. So what's going to happen at this point is any other information that needs to be more equally described, James will take the time to answer questions and kind of guide through that process.